Thanks very much, everyone. Good afternoon. My name is Attila from JPL. I will be talking about our GDGPS public products, supporting various applications, including scientific ones. So I'd like to acknowledge our co-authors, Larry Romans, who is a GDGPS chief technologist, and NASA and ancillary has been working with us as a postdoc. A few words about the actual talk. So I'd like to outline what the state of GDGPS is, what are those public products that we are making available to the community, what performance they show, how good those products are. So I'd like to compare them against CNES solutions, code solutions, as well as I will be showing some Galileo HAAS corrections. So a few upcoming developments. We will have a standalone JPL prototype client that is near to completion, and I will be also talking about some other GDGPS related science products. So what's the current status of GDGPS? So we process 6 constellations in real time. We capitalize on the global GNSS, real-time GNSS network, using GPSX, RTGX software at JPL. The nerve center of our processing technology are 3 GOCs, the GDGPS operation centers, 3 separate geographic locations, and they are being repositioned or consolidated to 2 GOCs, and I'll talk about a little bit later. Who are the users? The users' requirements are mainly for precise positioning and GNSS signal monitoring. We have government users as well as commercial users. We are more and more catering towards the science community. So I'll talk about the CDDIS products that's already out there and some other cool scientific applications. So this is the well-known network that we have been working with. 3 parts belong to it. So the IGS real-time network is an important part, about 100 stations that we are using. There are about 60 NASA-owned, JPL-operated GNSS receivers we capitalize on, and there are about 20 or so stations that are GDGPS operated, and they are separate from the other 2 networks. So about 160, 180 sites that we are using on a daily basis. These are the GOCs, GDGPS operation centers, and they are being relocated now to JPL and the JPL's data center in Las Vegas, Nevada. This is primarily because we have been asked to comply with NASA security requirements, which is also known as FISMA. So here is the first set of products I would like to bring to your attention. We first announced them at AGU last year. So these are the file-based products. If you go to CDDIS website, NASA's primary space geodesy data archive, on the lower right corner, you'll see the GDGPS products. These are all spelled out here. So basically, we have high-rate clock products, 1 Hertz GPS, GLONASS, and Galileo products, orbit products, and ancillary products, including attitude, quaternion information, antenna phase maps, antenna phase center products, as well as Earth orientation parameters. Another important set of products are here on the right. These are the ionospheric products, so we are uploading those products also in real time. So these are the streaming products. Streaming products are 3 pairs of products, redundant products. These are GPS plus GLONASS, GPS plus Galileo products, so 2 redundant streams. And we also have the broadcast products. So these are all 1 Hertz products. If all you need to do is have an account at at the CDDIS website, the Earth data account, and you will have access to all the 6 streams here. Next, so what's the performance of these products? So these are the performance evaluation I did. There were 38 stations we identified globally. The POD stations as well as the PPP stations are plotted here. So we identified 2,000 overlapping 3-hour segments of data, and 7 days worth of data were looked at in total. So here is the first set of performance metrics. So on the first line represents the horizontal performance, the second line the vertical performance, the first column on the left is the convergence time, they all reference to 20 centimeter horizontal and 40 centimeter vertical. That is similar to the what happened here? How do I go back? Oh, sorry, okay, now I got it. So here's the so I like to point out that the horizontal convergence time about 10 meters using GPS plus Galileo, and the vertical accuracy about 15.8 centimeters using GPS plus Galileo. Moving forward, the UREs, another important measure for performance. We looked at the UREs for GPS, the upper level. The lower level is the Galileo. So it's, the URE is about 6 to 6.5 centimeter that we achieved. The Galileo is about 7 centimeter. This is in good agreement with other centers UREs. And the GLONASS UREs are not representative here because we had to remove the intersignal biases. The latency is about less than 6 seconds. Moving on to the cumulative errors, cumulative distribution of the errors, separately for GPS plus GLONASS and GPS plus Galileo. They all show similar performance. The different streams perform very similarly, except I would point out that the comparison with the CNES is actually slightly outperforms JPL solutions. Is this because there are a couple of outliers we found in our data set? The blue represents the Galileo has accuracy. The reason the Galileo has is a little bit lower is because they only use about 14 tracking stations globally. So they are increasing the coverage in the southern hemisphere. So we expect also the Galileo has to improve. Now we are moving into the standalone JPL client. This is currently at the last stages of development. So standalone meaning we will be able to license the standalone client in the near future. The one example that I'd like to show here is the recent earthquake in Taiwan on April 2nd. So on the left you see the PPP client performance at the earthquake time, and we also post-processed it with RTGX, GPSX RTGX, and the two align fairly well. So this is what you would expect when the seismic waves arrive at the station, that you would see several centimeter level real-time displacement. So this is very important for the shake alert application in the western coast of the United States. So several users, several government entities expressed interest using the new JPL client for shake alert purposes, validation purposes. Moving on, another cool applications that comes out of GDGPS data streams are the coupling between the solid surface and the ionosphere. So the same Taiwan earthquake was looked at not only just the vertical displacement point of view, but also the ionospheric data stream was investigated. So on the right, that you see the three different constellations, Galileo, GPS, and GLONASS, showing the tsunami-generated ionospheric perturbation. So during the earthquake event, not only seismic waves, not only acoustic waves, but also gravity waves were generated And using GDGPS ionospheric data streams, we were able to see about the 0.2 THC level fluctuations in real time. This is important because that could potentially contribute to an early warning system that is based on ionospheric data streams. An interesting caveat to this, so the coupling between the solid surface and the ionosphere could be masked by space weather. Space weather is the coupling between from above. So how can we distinguish between geomagnetic storm induced ionospheric disturbances or solar induced disturbances? So this is one particular example. We have a real-time data stream that shows the geomagnetic disturbances. If you go to the guardian.jpl.nasa.gov or go directly to this website shown below, you will see the real-time ionospheric behavior. So we should be able to distinguish between the geomagnetic storm impact from the actual coupling from below. So we are also currently making two machine learning algorithms that we are actually adding to the Guardian system, the ionospheric, real-time ionospheric natural hazard detection system. And this Guardian system will be able to show you if there is any suspect signal that may be related to earthquakes, tsunamis, or volcanoes. So all this data is currently being uploaded to CDDIS. So if you are interested in working with us, or if you're interested in looking at the data yourself, you will be able to download the data for your investigations. So in summary, so we are currently moving on, releasing all our products to the public. So this is a process that we have been going through. So I showed you two sets of products, the file-based products and the real-time streaming products. So we would like to be working with you. Tell us what products you would be interested in us providing to the science community, and would like to help you achieve that goal. The current products I mentioned, the streaming products, and the prototype JPL client I mentioned, and also the real-time ionospheric products that might be of high interest to some of you. I already know who among you is working or very interested in working with ionospheric products, and if you are interested in working with us, I would love to continue working with you. So with that, I conclude my presentation. Thanks very much.